Next slide, please. Thank you all for taking the time to join us today. We do appreciate your consideration in regards to the reschedule here to navigate attendees being at the HIMSS conference in Chicago a few weeks back. My name is Christopher Rolnicki. I'm a Sales and Marketing Manager here at Chris Services Group. I'll be leading off the presentation today. And then the majority of the technical piece will be delivered by Ravi Vuruturu, who is he's our in-house DevOps or Azure DevOps practice architect. Next, please. So what Ravi will be walking us through today is just very briefly, Chris Services Group, who are we? And then discussing Azure for healthcare, specifically the Azure API for FHIR, FHIR utilities, Smart on FHIR, use cases and solutions, and then a demo. I ask that during the presentation, any questions you may have, stick them in the chat. We will get to them as quickly as possible. If they aren't answered immediately, we will circle back to them at the end of the presentation. We'll be opening up mics for discussion. We'll have an optional 15-minute Q&A period where we can discuss anything you may have heard or have questions about during the presentation. Quickly about us, we are your trusted digital transformation partner. What that means is we partner with our customers in their modern workplace, meaning Microsoft 365, and application modernization, pointing at Azure journey. Our innovative end-to-end cloud solutions streamline your business processes and allow you to focus on the growth of your business. Again, pointing at the last slide, our claim to what we are. Why partner with Krish? Trusted Azure DevOps partner, trusted software development partner, focus on application modernization, very experienced in Power Platform, Microsoft 365 migrations, enablement, so on and so forth, with cloud managed services and Microsoft 365 managed services to support your team as necessary. Industries we serve. Yes, this is a healthcare specific webinar, but we are industry agnostic in the industries that we serve. Yeah, same thing. Microsoft 365 migrations and upgrades, Power Platform, custom apps and web parts. On the Azure side, cognitive services, Azure serverless, logic apps, web apps, mobile apps, web APIs, Azure DevOps, integrations, so on and so forth. Okay. All right. I think this is where Ravi takes us away.
Yep. Hey, thanks, Christopher. Hello, everyone. Today I want to quickly talk about Azure for healthcare a little bit, and then slowly get into the Azure healthcare APIs and how that helps us to exchange the data securely and persist the data securely on Azure, and what Azure can provide in terms of FHIR. So, Azure provides a set of different services that helps to in different aspects of healthcare, right? We have Azure AI and machine learning services that are like helping to analyze patterns and make predictions that helps to make quick clinical support decisions. Or we have like Azure Synapse provides a great platform to analyze large volumes of data. That could be like patients' data or operational data that helps you make decisions. We have Azure Healthcare APIs, which makes the interoperability an easy thing when it comes to persisting patient data or providing a platform for secure exchange of data, right? Today, we'll be talking more about the healthcare API space, specifically Azure API for FHIR, FHIR. So this is more like a technical overview of what Azure provides when it comes to healthcare APIs, right? So if you look at this picture from left to right, it depicts how data is being received, how it is being persisted, how it is being analyzed, and how it is being shown to users on different types of platforms, right? From left to right. So when we think about data, healthcare deals with different kinds of data. It could be data coming from IoT, like Internet of Medical Things. IoT devices evolved over time along with the remote patient monitoring, and produce a lot of protected health data that needs to be reported to servers that for analysis or for monitoring of the patient, right? It could be that kind of data, or it could be data from labs. It could be data for like omics, right? Or that is the images that is being produced in the hospitals. Or it could be just the billing data or data from any external parties. All these different kinds of data that we need to process. Yeah, and Azure provides a single platform to ingest and persist the data. For example, what you're seeing here in the center is in the persisting line, swim lane. What you're seeing here is the healthcare APIs, right? For example, you see here medtech services. So medtech services you see here provides a platform that allows you to ingest data from a wide variety of devices, and it has ability to process different kinds of data and normalize that into standard file format, right? It has connectors with different wearable devices. It could be, for example, Apple Watch or Fitbit or Google Fit. It has connectors with all those kind of wearable devices. From where it can take all the data, it can normalize, it can convert that into file format and store it into a FHIR service, right? That's what, in a nutshell, what a medtech service is. Also, you see there at the top, the DICOM service, right? DICOM is nothing but digital imaging and communication in medicine. So this service has ability to ingest and process like thousands or even tens of thousands of images per second. It facilitates communication and transmission of this imaging data with DICOM web-enabled systems or applications via standard APIs. So the last but not least, what we have here in the last here, the persist lane is the FHIR service. There is a way to ingest FHIR data and persist it. It's a managed FHIR compliance server, provides enterprise-grade API endpoint for FHIR data access as well as storage. Once we have data in any of the services, these APIs provide export functionality to get them to any different services like Synapse, Databricks, right? These are the key. Some other services on Azure that will help you to receive the data from these services and analyze them in order to build reports, or if you want to develop any kind of machine learning models. So for all the analysis purposes, you can export the data from the services, and I will show you there are multiple utilities and tools which will help you to do that. So in Azure ecosystem, as you see here, this provides a service for every lane, like be it ingesting, processing the data, analyzing the data, and exporting and sharing the data with different user base here. So as I was explaining earlier, medtech has ability to connect to wide range of devices, be it wearable devices or equipment at a hospital. medtech service has a lot of integrations to get the data. It has capabilities like normalizing the data into a normalized schema and grouping the data based on, it could be measurement type, or it could be the device identifier. It can group the data, normalize the data, and convert that into like a FHIR observation record and store it in a FHIR service. when it comes to the actual the FHIR service or the Azure API for FHIR, Azure allows you to speed up the service in like just few minutes and have support even for older version of FHIR file data that is different formats. I mean, R4 is the latest version. We have older versions of file format too, so it supports everything, and you should be able to speed this up in like less than 3 minutes. So this is the platform as a service offering, obviously, so you don't have to worry about maintaining the resource. Azure takes on the workload of operations. It could be maintenance, updates, or compliance requirements, all those things. Azure will take care of it. When it comes to networking, just like any platform as a service, you can have private endpoints to protect your FHIR service easily from exposing to other traffic or internet or even traffic from Azure services, right? Also, capabilities like customer managed encryption keys that allows you to encrypt your own data at rest using your keys. You don't have to rely on. I mean, we have two options: either you can use customer managed key or vendor managed key. In that case, Azure will give you the key to encrypt the data at rest. So, I mean, all of these features are good. I mean, this will allow you to concentrate and give more time on how to better use the data and share meaningful insights which your patients or providers will in this case. So these are some of the advantages of Azure API for FHIR. As we have been seeing, there are many advantages to use Azure API for FHIR. I mean, FHIR, end of the day, a file is just a format. It's a specification that is defined, right? But how we implement it matters. That is where Azure has all this capabilities that it can offer, which makes it easy to ingest and process the data. So also when it comes to advantages, it has like built-in security tools using Azure RBAC. If you're already in Azure, I'm sure you are familiar with Azure RBAC, which gives you predefined roles to perform any actions. Just like that, in case of Azure API for FHIR, we have different roles like FHIR data reader, FHIR data writer, or FHIR data exporter. So depending on what you're doing, you can easily assign those kind of roles to any applications or people to get the job done. And also it has inbuilt tracking or track all the requests of the file data. So any action that you're performing on these objects, be it creation, modification, deletion, anything will be logged, and audit logs will be available without you doing anything. That's one more advantage with platform as a service. When it comes to compliance, we can apply Azure blueprints. Like I mean, there are different blueprints, right? Depending on the compliance, what you're going after, if it's SIPA, FedRAMP high, FedRAMP baud rate, depending on the compliance you're going, you can apply those blueprints to the services and make sure that you stay in compliance with all the access controls. Also, easy integration using Smart, right? As you know, FHIR defines the structure of the data, where it defines the structure of the data, where it should be and how it should look, right? But the real interoperability comes into picture when we make it easy for all the developers out there to easily deal with this data, at the same time easily develop applications using this data, right? So that is where SMART comes into picture. SMART is an acronym for substitutable medical applications, reason technologies. SMART on FHIR uses the standard authentication protocols like OAuth authorization, like OpenID, to define the authentication and the authorization standards, workflows for the developers to use. There are 4 different types of workflows where patient, I'll explain you later in the presentation, but it defines a standard way of how you authenticate and how you access this data, which helps the developers around the world to build build applications easily in a uniform way that can be used. At the end of the day, the goal for Smart is developers should be able to write any app once and expect it to run anywhere in the healthcare system. Right? That's the goal there. And one of the main advantages Azure API for FHIR will provide you is there is an easy integration with this Smart applications. Just to show you how Smart applications work, let me go ahead with the browser. If you see here, Smart, they have an app gallery here, and different organizations or individual developers, they develop these applications using Smart protocol, which allows them to which allows everyone to use these applications for any kind of data plus file data, right? So for example, this is if you take this application like cardiac risk, right? This is developed by Boston Children's Hospital, but this could be used by anyone because it used the Smart protocol, and as long as you have a file data, you should be able to use this pretty easily. You can view here, you can see more data about this thing, or also I can try the app here. So right now, when I click on try app, what's happening here is it is just working with a sample file data store in the backend. So as you see here, all these patient names are coming from a sample file data store. I can just select a single patient here, and you see this is the actual Smart app, right? So when I selected the patient, it was able to get the data for the patient in the background and showing the cardiac risk score here, right? So these are more like reusable standard apps. For example, if you have your own data on Azure API for FHIR, you can easily get this cardiac risk app and integrate with your Azure API for FHIR and use these applications without any issues. So that's the interoperability that as well as the standardization that we are that is possible using Azure API for FHIR as well as the Smart applications, right? Let me just back in the presentation. So along with different services that we talked about so far, oops, sorry, let me just clear this. Along with the different services we talked about so far, we have utilities that are available that supports the platform, right? For example, FHIR load is a utility that can load bulk data into the service. It can be integrated with the Azure event grid or storage accounts that can process and ingest the data. Everything that is needed for reliability, like throttling mechanism, read mechanism are inbuilt. It's easy to deploy and use. I have a demo created for this, and I will show you in a bit. And again, the second utility we have here is the FHIR converter. All of us know where we are working with different healthcare providers and different third-party vendors. Not all of us use the same format, and there will be instances where organizations might still need to work with legacy formats like maybe HL7 or CDA. So we have utilities like FHIR converter that help us convert the data to FHIR format before ingesting. This tool uses templates to basically uses like a templating language to map the data from whatever format that you receive and to the FHIR and convert the data from this format to FHIR format. Again, there is more utility like FHIR analytics pipeline. And so for all the tools we have seen will help us convert and ingest the data. Once the data is ingested, we need some way to continuously export the data to resources like Synapse or Databricks for analysis, right? So this is where the tools like this will come in handy, which allows to use the export endpoint of this FHIR service and get the data for every 5 minutes here. I just seeing in the picture, and all this utility is available right up there as the open source software tool. So all these utilities we have seen so far, right? Those are all open source softwares. I'll share these links also with you. For example, here you can see the Microsoft File Loader, File Converter. These are all open source software that is available. You can use them, deploy them as is, use them as utilities to convert them, input and ingest the data. Let's go back here. I mean, when it comes to use cases, of course, with the rise of all these wearable devices, personal health record owning the data of the personal health record became very essential these days, and that calls for more interoperability, because if when the patient itself own the record, how are they going to share the records with the healthcare providers, or how are they going to download the data and see what's happening, right? So all of these things that need to happen needs a standard format like a FHIR format. So patient health record is becoming one of the popular use cases when it comes to FHIR, right? So even modern apps, like for example on your iPhone you see Apple Health app, even that uses smart protocol that allows you to share your personal health record, electronic health record with any of the providers. Whenever if you go to your Apple Health app, you can just click on share. You will be able to see all the participating healthcare systems, and you can just log in the system, and it will take care of sharing the data of your data on your phone to the healthcare provider, and that is all being possible because of protocols like SMART. So the same thing with clinical decision support, clinical document sharing. All of these things need standard formatized formats like file format in order to securely exchange data between systems, and all the systems can easily understand the data. So one more use case here that we have here is patient transfer use case. This is the most common use case which could happen. Transferring the patients from one hospital to another hospital. When you are transferring the data, this FHIR format will be very useful. Having said that, I'll show you a quick use case here. Whatever I showed you earlier, right? How this all works, and this is the high-level architecture diagram of the use case that I'm going to show. There is a Azure API for FHIR that is installed on Azure, and this is the platform as a service that we have been talking about so far. And I have like a Azure App Service dashboard which reads the data from Azure API for FHIR and displays it on a web screen. And also I have a storage account where I can view more patient profiles. For example, in this use case, what we have seen is if we are receiving a patient record from one healthcare system to a different healthcare system in FHIR format, how are you going to load using that loader utility that I talked about, right? So I'm going to show you those things. So if you let me go here, so all the resources that I've showed you on the PowerPoint presentation are deployed in here. You can see here, this is my Azure API for FHIR called Winrar 0419, and this is a function app, which is nothing but the importer. So I have a storage account. So that means, as I told you, there is this utility called importer that is running in the background. If I give any patient profiles in the storage account, it should be able to read the patient profiles from the storage account and put them on Azure API for FHIR. And once we have data in here, we have a dashboard Azure App Service. It's a web app that reads the data from my Azure API for FHIR and displays them on a web app. So this is the web app that I was talking about. Let me just refresh. As you can see, I have only like 2 patient records right now, and this web app is reading the data from my Azure API for FHIR in the background. If you see here, there are 2 patient records, and again, I can go inside these records. You can see all the conditions for this particular patient, and again, all the encounters, all the observations. So it is just getting the data from Azure API for FHIR and displaying it here, right? So how is the import working? I also have a simple program called Cynthia, which will generate sample patient data just to demonstrate how it is all works in real time, right? So using this, I'm just going to generate a sample patient record. So Cynthia is nothing but like a test utility used by you can use the developers to generate this sample patient records, right? So yeah, as you can see here, it's looking at all the modules and creating some fictitious data and a fictitious patient record in the FHIR format. So that can be used to ingest. Just to show you the ingestion, I'm just generating these things. As you can see, it is going through different things, generating all these JSON files, and basically the goal here is it creates a patient record. So for example, in here, it created like a tray 250 patient record. It's a fictitious record, like from Massachusetts, and 30-year-old male. So as you see here, there is a photo called output. I can go in there. So it created a patient record in a FHIR format, right? So if I take this data, whatever is created by this utility, and go in there, go to my storage account, and just simulating a real-time scenario here. If you receive a patient record from a different healthcare system, how the result work, right? So if I go here in containers and the chat import, I just upload that here. Copy the plot here. As you can see, I just uploaded. I mean, it just takes a minute for it to ingest all this data. So this storage account is hooked up with our Azure function. The important function that I just showed you. Ideally, once we give this patient records, it takes the patient records and ingest them in our Azure API file. And the goal here is once it is ingested, you should be able to see them from the dashboard, just like that of the patient records that we have seen. It is just taking a little bit of time here because the Azure function that I have there is running on a lower plan, I believe. Let me just oops. just gonna give the restart. So it's up. Just regards. Yep. As you see here, it picked up a couple of regards already. Once this is done, what we are expecting to see here is we should be able to see a new patient record here. Processing. And meanwhile, if you just want to see how these records are generated, you can see there is practitioner information, hospital information, actual patient information. Yeah, this is all in file format. I can just open it in a notepad. You can see there is a type is called patient, and status is generated, and there is a lot of data about ethnicity as well as medical record number. These are all like PII and PHI information. Of course, it's on fiches. We go back here. Yeah, it is still being processed. Regardless, as you get the idea, once that is in this process, it's processed. So you can see the third patient record here, and I can get in here. I can see all the conditions that were generated, as well as the encounters, the child visits, emergency treatment, all the encounters here. All this is possible because of a standardized format. You can use this ready available utilities to easily ingest and process the data here. And as you see here, this is the kind of format that my application is receiving from the Azure API profile background, and I'm displaying that in the different format here. So I know I'm a little over like 3 minutes over here. Any questions so far?
I just opened up everyone's mics. So if you have any questions you want to unmute and ask those, please feel free.
So Ravi, for existing data to be brought into that converter, how much work do we have to do to line up the different fields? I saw the loin code in there, LOINC. How much of that's handled by that converter?
It depends on the format of data that we are receiving. For example, as I mentioned earlier, it all depends on the templating, right? We need to define templates on like you are receiving this data, a source data, and you need to map every field in the source data to destination data. So what we use called fluid templating language to define those templates. Templates are already available for some standard formats like HL7, but if you have a specific format like a custom JSON that you're receiving, but still you want to convert that data to your file format, then you might need to develop some templates to read the data and exactly map to the FHIR resource types and generate the FHIR observation records or patient records or anything that we need to do. So there are some standard templates available, but there is customization available too. So you can have your own templating language or template available to map the data accordingly.
Yeah, thanks.
Any more questions?
There's one in the chat there. The
Yeah.
practical use cases on the revenue cycle back office side.
FHIR mostly deals with the patient data here on the resource sides, be it observations or be it encounters. FHIR deals with the patient data, but the back office, obviously, as I showed you in the initial picture here, it doesn't matter what kind of data that we are receiving, be it the billing data, some kind of imaging data. We have different services available on Azure that follows that will help us to ingest and process the data and export them for analysis or share with any kind of apps, like smart apps.
Does that answer your question, Helen? Thank you. Yes. Okay. Any more questions here?
And doesn't see the chat if there are any.
No, I think we're good here, Ravi. If you have anything to finish up, barring any last second questions, I think we're about ready.
I know these are all very deep topics. What I just showed you is more like a one-on-one for all of these things, and there is more involved in it. If you would like to see more on a specific thing, please feel free to reach out to me or Christopher there. I'm more than happy to jump on a call with you and talk about some of these things more.
Awesome. Well, thank you everyone for attending today. If you have any further questions, please don't hesitate to reach out by email. As Ravi mentioned, we're happy to discuss any of these topics in depth with you. Again, just following up by email, we'll get some time booked on the calendar and we can talk through it. Just thank you all for attending. We hope you found it informative. I will be sending out a PDF of the slide deck as well as a link to the recording here this afternoon. Again, thank you all for attending, and we hope to see you here in the future. Thank you all.
Thank you.
Bye. Thanks, Ravi. Thanks, Christopher.
Thank you.